Hi children, in this session we will prove another theorem from the same topic, similar triangles. In order to prove that theorem, we should know two important things. Let us recall those two previous knowledge. The first previous knowledge that we should know is all about area of a triangle. In this triangle, if this is taken as the base of the triangle, to this base, the shortest distance from its opposite vertex is this. From here, the shortest distance is called altitude. That we are taking as the height or altitude. That is, the formula is very simple. Area of triangle A is equal to half into product between base and the height. The second previous knowledge is about similar triangles. Similar triangles means the corresponding angles are equal. Similar triangle means the ratio of the corresponding sides are equal. That is, the sides are in proportion. Example, here you see, if I consider the two triangles, a baby triangle and a mother triangle, that means if I give the names to these two triangles as ABC and PQR, then if angle A is equal to angle P, angle B equals angle Q, and angle C equals angle R, using the previous theorem, I can say that the corresponding sides are in proportion. That is, AB by PQ is equal to BC by QR, which is also equal to CA by RP, the third side. So these are the two previous knowledge which we have to know in order to prove this theorem. Let us consider the statement of today's theorem that we have to prove. Statement says the areas of two similar triangles are proportional to the square of any one of its side, that is corresponding side. So as per the statement, we need to draw the diagram. The statement is all about the areas of two similar triangles. So let us consider two triangles which looks like similar. Okay, here comes. We need to explain the diagram which we have drawn in our own sentence by taking the side heading as data are given. For that, give the names to these two triangles as ABC and PQR. Then in triangle ABC and triangle PQR, the statement it is given as the two triangles are similar. That means they have to be equiangular. That means the three corresponding angles must be equal to one another. Out of these three, let me consider one of the angle, and here I am considering angle B and angle Q, which are corresponding to one another. And similar means the sides must be in the same ratio. That means the sides must be in proportion. Out of the three sides, let me take any two sides which are in proportion. So here is AB and PQ are the corresponding sides, their ratio, and the second side I am taking BC and QR. They are in the same ratio, that means they are in proportion. Let us give the number to this as equation 1. So this is the data. After data, the next thing comes is to prove. The statement says areas of the similar triangles. That means the statement is dealing with the areas of the triangle. So the two triangles are ABC and PQR. Proportion means I need to divide the two areas. Okay, so area of triangle ABC and area of triangle PQR is proportion. Proportion means I have to divide another parameter here, and it is nothing but square of the corresponding sides. So out of the three sides, take any one of the side. Here I am taking BC and QR. So square of the corresponding side means BC square by QR square. It means BC into BC divided by QR into QR. Okay, to prove, done. After to prove, the next task is we need to prove this, but the information given in this is not sufficient to prove this theorem. So we are taking a lifeline here called construction. So what I'm doing is, since the topic is about areas, and we know that area means the formula half into base into height. There is, I can take any of the side as base, but I am not finding the height here. See, in triangle ABC, I am considering the altitude here. Dotted line means construction. Similarly, in triangle PQR, let me consider a dotted line, altitude. Give the name to those two altitudes as M and N. That is, AM and PN are the two altitudes drawn in triangle ABC and triangle PQR to the sides BC and QR respectively. Let us explain this by taking construction as side heading. So AM perpendicular to BC, PN perpendicular to QR is drawn. After construction, now proof. That is, let us start from the left hand side of the task assigned. The left hand side says area of triangle ABC divided by area of triangle PQR. So if I write that, what is that we are knowing about area? Points to remember, one says area of triangle is equal to half of the product of base into height. Let us apply for both the triangle ABC and PQR. That is, area of the triangle ABC is equal to half into base, which is the base in ABC. I am taking BC as base, and in PQR I am taking QR as base, into height. So BC to this BC, the corresponding height is AM, and for QR corresponding height is PN, altitude, shortest line. Okay, but here 1 by 2 and 1 by 2 will get cancelled. So let us cancel those two. Now remaining factors of right hand side is BC into AM by QR into PN. Let me take this as equation number 2. Now the task is area of triangle ABC divided by area of triangle PQR is equal to BC square by QR square. It means BC into BC, QR into QR. Instead of BC into BC, here we have got it as AM. And QR into QR, we got here as PN. So what we need to do? We need to replace this AM by PN as BC by QR. In order to do so, let us consider the two baby triangles, and they are triangle ABM and triangle PQN. We need to prove that these two triangles are similar using AA criteria. So first angle, I am relating angle B and angle Q are equal. How do we know? It is given data. So let me write the reason here as given. So this is one of the angle, and to use AA criteria I need one more angle, and which is that? Here is angle M and angle N. At this vertex it is right angle because altitude. How do we know that it is 90 degree? Because we have done that in construction. So let me write the reason as construction. So that means one angle, another angle, AA criteria, I can say that triangle ABM and triangle PQN are similar. Reason is previous theorem, AA criteria. But if two angles are equal, then the remaining angle, that is B and M I have taken, Q and N I have taken here. So B, M, other than these two, the remaining angle is A, and QN, the remaining angle is P. They are also equal. And we don't want any reason for this because sum of three angles is 180. That means the third angle must also equal, then only it can measure 180. So I am writing the reason as remaining angles. So this is A and this one is A. Using A criteria, I am writing triangle ABM similar to triangle PQN. Decide, write the reason AA criteria of similarity. If the two triangles are similar, then using the previous theorem, I can say the sides are in proportion. Is the three sides of triangle ABM and triangle PQN are in the same ratio. That is, they are in proportion. Out of the three, I am taking only two. Which are those two? Here is AB by PQ. AB, the corresponding angle of A is P, corresponding angle of B is Q, therefore PQ, AB by PQ. Then the second element is AM, angles are AM, the corresponding angle of A is P, corresponding angle of M is N, so PN here. So AB by PQ equals AM by PN. Let us call this as equation number 3. What is the use of this equation number 3? When you compare this equation number 3 with equation number 1, equation number you will find that in data. When you compare that equation number 1 and 3, you will find that AB by PQ is equal to BC by QR. Then in equation number 3, the same AB by PQ is equal to AM by PN. So using axiom number 1, things which are equal to same things are also equal to one another. On the basis of that, I can write BC by QR is equal to AM by PN. Let us call this as equation number 4. Now, use equation number 4 in equation number 2. That is, wherever you are finding BC by QR, you can replace it as AM by PN or vice versa. Wherever AM by PN is there you can replace it as BC by QR. Am I right? So that is, using equation 4 in 2, I can write area of triangle ABC divided by area of triangle PQR is equal to BC by QR into, replace AM and PN as BC by QR using equation 4. Now the exponential form of BC into BC is BC square, and the exponential form of this QR into QR is QR square. That is, area of triangle ABC divided by area of triangle PQR is equal to BC square by QR square. This is what the proof of this theorem. I hope that you have understood the proof of this theorem. The statement of the theorem says the areas of two similar triangles are proportional to the square of the corresponding side. We can extend this statement as the areas of similar triangles, they are not just in proportion with only the square of the corresponding sides, they are also in proportion with the perimeter of the triangles, and also they are in proportion with the square of their altitudes. They are also in proportion with the square of their median. That is, I can extend the statement of this theorem as the areas of two similar triangles is in proportion with the square of the perimeters of the triangles. The second thing is the square of the altitudes. We can draw three altitudes in a triangle. So corresponding altitudes. Also, the areas of two similar triangles is in proportion with the square of their median. Median means it is a line drawn from any vertex of the triangle to the midpoint of its opposite side. That line is called as median. So this is how we can extend this statement of the theorem. Thank you for watching. Next time we will prove Pythagoras theorem.